I know that some of you want to take the test on Thursday, which I fully support and even recommend. And so I want to make sure you had all the information you need going into it. So I'm going to put this here so we have everything we need. So I'm going to finish up with obstacles to problem solving and talk a little bit about creative thinking. And just as a reminder, remember some of the obstacles to problem solving that we looked at already would be confirmation bias, fixation, and mental set. And continuing with obstacles to problem solving, another one would be emotional barriers. So, this inhibition and fear of making a fool of oneself or of making a mistake. This is one of those things that we're actively trying to work our way around in class. It would be why you would, you know, celebrate the good things for sure, the woot woots and the woots, and even the wahs, depending on the day, but also the hang your head in shame or the whatever, write your name on the board. It doesn't matter. The whole point is that nobody cares and it's not a big deal. um, you know, that's it. Like, you make a mistake and it's no big deal. Unfortunately, we get to this age where we feel like we need to have already been good at something, and that's misleading. I feel like we need to actively model errors in front of people and how to deal with it and just be okay with that. But it is hard, and I say that as someone who obviously works the same uphill battle as everybody else on that. Really depending on the category. And I told you the story about my dad learning to roller skate in his 50s, and how he would basically dress up like the kid from the Christmas Story. He could barely move, and he'd inch his way down the street, and with the attitude of, I will do this at the same time every day for the same amount of time until I get good at it. And he did get good at it, but for a while he took a lot of spills, and he looked pretty funny doing it. And there were neighbors that used to come out of the houses and eat popcorn sometimes and yell things at him and make fun of him. And but he still learned to do it, and I think that was the lesson. So when one of the neighbors was over our house, and he saw my dad getting ready to rollerblade, he was like, "Oh, it's that time. Yeah, we usually sit in our house and make fun of you when you skate by." And my dad was just like, "Oh, you guys know how to skate?" He's like, "No." And he's like, "All right, well, while you're in your house making fun of me, I'm actually learning how to do it." So he was kind of beyond the caring what people think about it when it came to that sort of thing. As for cultural barriers, this belief, and this is as an example, this belief that fantasy is a waste of time and feelings and humor have no place in problem solving, it really depends on your culture how you'd kind of define this. But essentially, what's dictated by your upbringing, by your cultural background, these norms that are set. So if you come from a culture that that doesn't promote individuality, then you are going to see that reflected in your problem solving process. And conversely, if you come from a culture that does promote individuality, you're going to see that reflected in it too. And it's a barrier in both ways, because in both ways you're limiting your possible options. If you're in a culture, whether it's a classroom culture or whatever, where you feel that there's this sense of us and them, or let's say that open communication isn't promoted, that would be a barrier to problem solving as well. And learned barriers, as examples here, are these taboos or staying within conventional uses. So if you're looking at a problem and you're putting in, say, unnecessary constraints, or you're loaded up with irrelevant information, or you have this notion that we all need to agree, these are things that you learn from being in whichever environment you're in. It's again, why it's so helpful to have that person. If you're trying to solve a problem, you want people with expertise in the thing that you're looking at, but you also want people who don't have expertise, because they're going to come up with these novel ideas, because it's some good and some not, but they're going to be able to look at something in a way that somebody who's really familiar with something cannot. A perceptual barrier, as I have here, habits leading to a failure to identify important elements of a problem. Sometimes this is where, you have a particular way of seeing something, and obviously your constructs are going to be controlling this, the lens with which you are looking at stuff, the question somebody asks, what they ask you to pay attention to, that sort of thing, causes you to look at something a particular way. So stereotyping could be an example of this, having these preconceived notions about something. But in one way or the other, you're really only considering the obvious information. So you've essentially set up this cognitive boundary. So, like, if you tell me, you know what, like, I couldn't do the homework last night because I was so tired, I was exhausted, and I say, okay, you know, like, we move on to try to solve the problem of, like, the homework and what needs to happen with that, instead of sort of backing up and being like, okay, what are all the things that led up to this night where it was hard to get, like, a homework assignment done? And as sort of a simple exercise, if somebody who knows how to play chess looks at these two board setups, you'll see the one on the left is from a real game, and the one on the right is random placement. Like, if you know anything about chess, you look at the situation, this game could not happen. Like, these pieces can't be where they are. It's not even possible to play a game like that. That's clearly random placement. Could you have a game that looks like this? That's possible. Still looks like a little bit of a strange game, but it's possible. Now, if I asked you to try to remember this so you can recall it later, if you play chess, the board on the left would be easier for you to remember than the board on the right. So making decisions and forming judgments. So when we consider the problem-solving process, a representativeness heuristic is going to play into this. I know we already talked about what a heuristic is, so I'll get to the specific meaning of this. But remember that heuristic is a mental shortcut of types. Let's look at this problem. Linda is 31, single, outspoken, and very bright. She majored in philosophy in college. As a student, she was deeply concerned with discrimination and other social issues, and she participated in anti-nuclear demonstrations. Which statement is more likely? That either A, Linda is a bank teller, or B, Linda is a bank teller and active in the feminist movement. And before we explore that, let's look at another example. Ernest is extroverted and literary. Which of the following is more likely? Ernest majored in engineering, or Ernest majored in engineering but took a job as a newspaper reporter. Okay, so when we look at the first one, right? So Linda, what I want you to notice is you were given all of this information about her. You were told that she is 31, single, outspoken, very bright. She majored in philosophy, deeply concerned with discrimination and social issues. She participated in anti-nuclear demonstrations. Like, there's a lot of information there that might make you believe that Linda is a bank teller and also active in the feminist movement. And I'll explain specifically what's happening here, but what I want you to pay attention to is the word and. The word and is the thing that's making this a lot less likely. Linda is a lot more likely to be a bank teller. The same is also true in the case of Ernest. You have less information that you're working with, but if you look at it, extroverted and literary, you might think, sure, majored in engineering, but took a job as a newspaper reporter, but no, you're getting more specific there. It's not likely to be true. What you want to focus on is what's statistically more likely. And that's what you don't do when you're doing a representativeness heuristic. You look at like the character of the person and then you think, oh yeah, these things are more likely, but as soon as you add anything on, it becomes less and less likely to be accurate. So here for the definition of representativeness heuristic, judging someone on the likelihood that they fit a certain prototype. And let me remind you that prototype is the most typical example of something. And then you're going to ignore all other relevant information. So if someone is short, slim, and likes to read poetry, and you are asked, are they a truck driver or an Ivy League professor, you might think, well, you know, the poetry part especially might throw you off there. And you might think like, oh yeah, more likely to be an Ivy League professor, but there are a lot more truck drivers than there are Ivy League professors, so the truck driver part is still the more likely scenario. Really what's happening here is that you're judging the likelihood of an event based on a comparable known. From there, you assume that the probabilities will be similar, and that's where the mistake gets made. Because a similarity in one aspect does not actually mean a similarity in other aspects. And when we look at the gambler's fallacy, this belief in runs of good or bad luck, this would be another example of the representativeness heuristic. So if I'm doing like a coin flip and I'm flipping the coin, and tails is coming up a lot, right? I keep getting tails. Then the assumption is, well, like heads are due. But like actually, no. Every time I flip a coin, a fair coin, each outcome is just as probable. So, like if I told you about a professor who thought that he could figure out the winning lottery numbers by determining which numbers have come up more frequently to see which numbers are sort of due, doesn't work that way. A lot of people misunderstand statistics that way. Let's say, for example, that someone goes in for a fertility treatment. Let's say they go in for like an IVF, and let's say they're told by their doctor, all right, well, you have a 50-50 chance of it working, and therefore, in 2 tries, it's going to work. No, actually, if the chances are accurate, you have a 50-50 chance of it working, that means you have a 50-50 chance each time of it working. The law of small numbers is another type of representativeness heuristic. This is the assumption that people make that a small sample is representative of a much larger population. But again, stats don't work that way. We talked about like, okay, you should have 30 in a sample, and not even just any sample, one where everybody in your population has an equal chance of being selected. Which is not true if I meet, say, 30 people at, like if I want to find out about Ardsley High School, let's say, and what the kids are like there, and I meet 30 people at a baseball game, or a football game, or after school table tennis, like every scenario I'm getting a different impression of what the school would be like because they're not randomly selected, even if I have a number of 30. But you can drop that number down so much and people will make big assumptions. How many times do you hear kids like say stuff like, oh, they don't like this particular kids from the school or whatever, not Ardsley, but like I hear Ardsley kids say that about other schools, like, you know, they have like, they're enemies with some other school. And normally it's like they met a couple kids there and they had a bad interaction. It doesn't, like, that doesn't say what the whole school is like, but they make that assumption. And I want you to notice that, like reason just goes out the window, even for people who understand stats, the same thing happens. So I'm thinking about working for a new company, let's say, and I meet 3 people there and I find them all to be like really aggressive. I assume then that the company has this aggressive culture and I think maybe I don't want to work there. And I'm not sure what this would mean to you, but it's just sort of funny to think about. So if you were to like think, what are Ardsley School teachers like? And you were to walk down the social studies hallway by my classroom and you're like, okay, you meet Miss Berman, you meet Miss Kim, and you meet me. You're going to get, I don't know what the impression is, but you're going to get an impression of us as a school. And if you take like a look at the wider group, we're not likely to be representative of the entire school in some meaningful way like that. I think that's the thing that people forget. If I have a really large sample, I get pretty accurate data. But if I have a really small sample, my sample is more likely to give me extreme data. The availability heuristic is a different type of really mental shortcut. And this is where we're basing our judgments on the availability of information in our memory. So essentially, how easily can we call it to mind? Is there a picture in our mind that like comes really fast to our mind, and we are going to assume it's more likely to happen? So when we hear about something, let's say tragic, like we hear about a rape case in the news, the assumption then therefore may be like it's not safe to go out at night, and many women, let's say, will be very nervous. But what we've really been done is we've been primed by the news to like have that come to mind really easily. Like I just saw something about that in the news, therefore it must be likely to be true. I remember years ago, there was I don't know what ended up happening as I'm thinking about it, but I feel like there's like a shooting in a mall. I don't remember what the like result of that was, but I remember a lot of people were like afraid to go to that particular mall afterwards because it was like all of a sudden the mall was unsafe. But if you think about all of the people that have gone through that mall over so many days, and while, yeah, that one thing that happened is awful, it's still statistically highly unlikely. And the thing is, it really doesn't matter how well you understand statistics. you're still likely to like have an issue with this. So that sheet that I gave you when I was like, okay, so like pick which one was more likely, and we can go over that in class, but what's the most frequent cause of death? Like, and we look at the first one, like all accidents put together or strokes. Well, the thing is that in your mind, you're like more likely to come up with accidents because that's more likely to be in the news. So since you can call it to mind more easily, it's more likely to be true. That's the thinking. Which country has a larger population? And when your choices are Morocco or Saudi Arabia, you might have stories of Saudi Arabia come to mind more easily, and therefore you guess that one when the answer would be Morocco. And when you look at which city has a higher crime rate, Chicago, Illinois, or Kansas City, Missouri, you're more likely to have heard stuff about Chicago, and therefore you pick Chicago when the answer is actually Kansas City. Overconfidence is another problem, so a tendency to be more confident than correct, or to overestimate the accuracy of our knowledge and judgments. Confidence tends to increase if we are given incentives to perform well. That doesn't scream a problem, I don't know. And overconfidence is greatest when accuracy is at near chance levels. So that's great. When our accuracy is more like 50-50, we become very confident. But as our accuracy increases, maybe like from 50% to 80%, we actually start to become less confident. Once our accuracy exceeds 80%, people start to become underconfident, statistically speaking, which is why it's sort of fun to say, guess what score you got on your test. Very few people seem to be able to like pinpoint precisely, or in and around even in some cases, what that would be. Framing, so the way an issue is posed, like a question I might ask or a construct, what have you. But the way an issue is posed, like a cognitive suggestion, can significantly affect decisions, judgments, and experience of a situation. It's one thing if you're going into a surgery and the surgeon tells you 90% of people will survive this. That's one thing. It would be so different to hear, well, 10% of people that have the surgery do not survive it. Very different feel, very different comfort level in having the surgery in the first place. I think it was in an old commercial where you used to hear 4 out of 5 dentists recommend chewing Trident after a meal when you can't brush your teeth. And but that they don't say is 1 out of 5 dentists don't recommend that. And the framing isn't something that's always provided to you like that. It could be also, coming from your lens. So if you find out that, okay, this week off you're gonna go on this holiday in the hills. Some people will be like, woohoo, gonna get some outdoor exercise, gonna explore around the woods, get in touch with nature, what have you. And, maybe see as a chance to maybe read or just get some sleep or whatever. And another person might look at that and think, God, like a week of absolute boredom. And that's your own personal framing effect. It even happens when you walk into a store. Like if you see something that's marked on sale versus something at the same price that's not marked on sale, you're just more likely to buy the sale item. Belief bias is another problem, another obstacle to solving problems. This tendency for our beliefs to distort our logic. People will tend to accept any and all conclusions that fit in with their system of belief without challenge or any deep consideration of what they are actually agreeing with. This is kind of why it's like kind of wasting your time a lot of times to get into an argument with somebody about religion or politics. They're not likely to change their mind. They're going to look for things that support, or they're going to look to confirm what they believe and not look to prove themselves wrong in any way. Throw on top of that some people will argue completely from anecdote and experience and not at all by logic. And that problem of belief bias really leads to this belief perseverance phenomenon. So belief perseverance is this tendency to cling to our original beliefs in the face of contrary evidence. This is made even worse by the fact that if somebody knows your belief or you've stated where you stand on something, it can become hard to back down from. And it's really difficult to change a belief that would cause an entire structure underneath it to become undone. To go back to that, religious belief system, if you start arguing with somebody about religion, for them to accept what you're saying, and I'm not suggesting that you should, but for them to accept what you're saying, It's going to undermine a lot of, in many cases, how they've been raised, how they've been taught. It's not likely to be the type of thing that somebody's going to be flexible on. Now, in the example of this study that I have referenced here, these experimenters asked participants to look at suicide notes to determine which were real. And they were looking at 25 notes, and a third of the participants were told that they were right 10 out of 25 times. Another third were told that they were right 17 out of 25 times, and the final third were told that they were right 24 out of 25 times. After they were given this information, they were then told that they'd been lied to, and they were asked to estimate how many they got right. And those who had been told that they had gotten a lot right in the first place, like 24 out of 25, continued to guess high because they believed then that they were good at determining which ones were real and which ones were fake. I can tell you once that I had gotten into maybe like probably a sort of useless debate with a student years ago. She was fairly disorganized, might be an understatement. I think, a lot of times when something went into her book bag, it was hard to ever find it again. And she was going to class, and it was time to take out her homework, and she knew that her teachers would only accept it if she gave it, if she produced it during that class period, that the homework wasn't accepted late. So she would start digging to her backpack to find where it was, and it would take her the majority of the period to find where it was, and meantime she's missing everything that's being said in class. So when I found out that this was happening, I tried to talk to her about it, like, okay, why don't we work on this outside of class? So let's take your backpack and, let's take your backpack, let's go through it, organize it, I'll find the homework, and I'll be the one responsible for handing it to the teachers. Because we're really working on organizational skills, but at the same time, we needed her to be able to attend to what she was learning in class, too. So that was the bigger priority. We'd work on the organizational stuff sort of after that. And she proceeded to argue with me that it was morally wrong to turn in her homework late or to expect some sort of exception from teachers. And I had already spoken to her teachers, and this seemed to everybody like a reasonable accommodation. But I couldn't convince her to go along with it because the stance she was taking was that it was morally wrong, that she shouldn't have an advantage that other students didn't have. Not seeing that having that level of trouble with organization was in itself a disadvantage. I spent one entire class period having this discussion with her, and I had like you would when you're trying to convince somebody of something, take them step by step with their own, working in their own belief system, bit by bit, arguing until finally she was going to have to concede that yes, this was what we were going to have to do. And as soon as she saw that I had kind of backed her into a corner on that one, she just dropped everything that we had just discussed for the whole period and went, it's morally wrong, and just dropped it. So I had to take another tactic, which was simply, okay, so if it's morally wrong not to do what your teacher tells you to do, then am I one of your teachers? And she said yes. And I was like, okay, well, this is your assignment with me. And that's how we had to work around it until we figured out how to help her with, the sort of executive functioning tasks that we needed to work on. I won't spend too much time here because I feel like you guys probably have a pretty good handle on artificial intelligence, but like computers and their programs that perform human-like problem solving or intelligent responding, like Deep Blue, the chess-playing supercomputer would be an example. Computer simulations or programs that attempt to duplicate human behavior, especially thinking or problem solving or decision making. In looking at creative thinking now, we have inductive thinking, inductive thought, also called inductive reasoning, or bottom-up processing. This is where you go from specific facts or observations and you try to come up with general principles. So if you guys are thinking, okay, well, Ms. Noonish likes to use PowerPoint. She's been using PowerPoint a lot, so therefore she'll probably use PowerPoint in her class tomorrow. You may or may not be right, but you're working with the data that you have to draw conclusions. Maybe I could take something like 3 plus 5 is 8. Since 3 is an odd number and 5 is an odd number, and 8 is an even number, I could draw the conclusion that if I add two odd numbers together, I get an even number. The key really here is you're observing something, you're seeing a pattern, you make a tentative hypothesis, ultimately you come up with a theory. Deductive reasoning is going in the other direction. So this is also called, or deductive thought, deductive reasoning, or top-down processing. So this is where you're going from general principles to specific situations. So to tell these two apart, I can kind of like paint in a scenario for you here. Let's say that you are, walking through the woods at night, and you see something that looks maybe like fire, or definitely light, or perhaps fire in the distance. You're smelling smoke. You're hearing some noise. You could be, you're building up these bits of information and, inductive reasoning to kind of come up with is there, a fire in the woods? Is there something going on? Is there a party? Are people having a campfire? And you keep building up information until you're able to come up with, a general principle. Whereas if you were invited to a campfire in the woods, which by the way sounds really unsafe, you're invited to a campfire in the woods, then you know what you're seeing. So when you see the same things, you see it under the lens of, I'm going to a campfire, and so all of the other options are off the table. If you look at a picture like this from inductive reasoning point of view, so I'm taking the information that I see until I can come up with a picture. Am I focusing on the people, the flower, what have you? Or, that would be inductive reasoning, as I'm kind of putting it together as I'm looking at it. But if I were to tell you you're looking at a picture of a flower, the flower is what you see first. And so if I ask you to remember details about it, you're going to first give me the details of a flower. I think I set the slide up backwards. Sorry about that. But looking at logical versus illogical thought. So logical thought, you go from given information to new conclusions based on an explicit set of rules. You followed a step-by-step, procedure to get yourself there. Maybe an algorithm. Illogical thinking is thinking that's intuitive, associative, or personal. So if I want to go through logical thinking to come up with solutions to something, I'm really going to look at the premise first, and I'm going to make inferences, and ultimately I'm going to draw a conclusion. In illogical thinking, I'm using more of my emotional sense. And finally, we have how to rate creative thoughts. So if you've ever seen that show, Whose Line Is It Anyway? They do that prop game, which we should really try. And you're given a certain amount of time and a random object, or random props, and you have to make a scene out of it. And I feel like the Whose Line Is It Anyway prop game scenes, if you just even Google some of that, you'll see all of these things on display. It's a perfect example for it. But in Fluency, if I give you a 2-minute time period and these like a random object, how many suggestions can you come up with? So we're looking really at rate. How many different things can you come up with to do with this item? The flexibility is how you can shift from one class of possible uses to another. So if I give you, like, say, a pool noodle, and I say, like, what can you do with it? And you think first in terms of swimming. All right, you stay in things that are involved in swimming. That's rather traditional. But maybe you move then to using the pool noodle as like jewelry. Like you're like, okay, so maybe it's a necklace or bracelet, big hoop earring, a belt, something like that. But you're staying in a group, like a group. So how many times can you shift to a completely different category, a different type of thinking? Originality. How novel or unusual are your suggestions? I've seen students come up with some really like unique, pretty awesome ideas when looking at, what to do with an odd object. So how unlike everybody else's ideas are your ideas with what to do with this object? For convergent thinking, this is when all of the lines of thought converge on an answer. This is more conventional thinking. So if you picture like the bell rings for 5th period lunch, and you see all these students sort of coming from all over the school kind of converge together to the cafeteria. When we ask questions on a test, like multiple choice or a standardized test, a spelling test, we're really requiring students to do some conventional thinking there. Then you have divergent thinking, so many possibilities developing from one starting point. This is where you're going to see more curiosity and inventiveness. So if I show you a photo, like how many different captions can you make for it? I think there have been times where one of my brothers and I have like gotten a picture of something or other, or taken a picture of something or other, and we send it back and forth, and we're just like, we keep memeing it. You know, some of them are going to be funnier than others, but it's like, how many different possibilities can we come up, can we come up with? If I'm going to be completely fair, though, he's, like, I'd like to say I hold my own, but he's far better than I am at this game. When it comes to the complexity of what you're thinking of, how many like different dimensions can you think of something on at the same time? How many different parts can you integrate? So if you take that prop game and it's like, okay, so one person gives an idea for something, if the other person's job is just to come up with another idea, which they do frequently, that's funny, right? But a harder task, a more complex task, would be to like take the information that the other person started with their props and build on that with your props, and kind of go back and forth like that, adding in dimensions that would be more complex. And imagination, obviously forming mental images of something that's not present to the senses nor wholly present in reality, coming up with something completely unique and out of whole cloth. And risk-taking really leads to creativity. So are you okay with like trying something out? Like, say like you want to say something funny, like you say it and it flops, like you've taken a risk, had an undesirable result, let's say, but then you move on and you try another thing. How willing are you to do that, to go out on a limb at the with the chance of it not working? Some examples of creative thinking: you look at these images down on, down on this side right here. And if you just take a second and think, like, what does that look like to you? What does this look like to you? What does that look like to you? And are your answers more conventional or are they more creative? So in kids that were sampled, a unique answer was more like a foot and toes. A more common answer would be a table with things on top. This one, unique answer, example, obviously, would be a lollipop bursting into pieces. More common would be it's a flower, or like a pinwheel. I'd actually like to see what you guys said to this stuff. This one here, a unique example could be 2 haystacks on a flying carpet. More common would be like 2 igloos. In this task here, the task would be to complete the drawing. And that's the only instructions, just complete the drawing. And so you start with each one of those shapes and you complete it. And if you draw that on your own paper, that would be interesting, and just see what you do. Complete the drawing, pause the video if you like, complete the drawing and see what you come up with. These are ordinary responses, where complete the drawing simply means like kind of close the shape in some way. So turning this one into a rectangle, turning that one into a triangle, just sort of closing this one off. I don't remember the source of this one, but the assignment was online at some point. Draw a duck and share your art. And so you get this image where you just see like a beak here and an eye and the feet, and that's it. You just draw a duck, share your art, and they presented kind of the more unique ones. And I'll show you this particular time what they thought were some of the more unique or creative ones, which I think would be very different. I think I'd be like really trying to just draw a duck. Obviously, some of them got political. This is more in line with something I can handle, I think. Can't even wrap my head around this. Okay, I mean, you gotta love that one. No mistakes, only happy accidents. I don't know why this one cracks me up. I like this one. It's really like thinking outside the box.